All right, in this last video, we're going to tackle the multiple variable conversions. Okay, so again, here we have our introduction to our mole conversions. And if we go to the second page of the document, now we have the multiple variable conversions. So it says here, these problems will require two conversion factors instead of one. So in the previous examples, we were only going between moles and volume or moles and mass. But now we're going to have two conversion factors instead of the one. Okay, so you are going to need your mole map. You're going to need a periodic table. And you are going to need your calculator. Okay, again, make sure your calculator is in scientific notation. Okay, remember, go to view and you can change it to scientific. Okay, so the mole map, we're going to be dealing with how do we go, for example, from mass to volume. There's no direct route. There's no conversion to go from mass to volume, right? On the left-hand side, there's nothing there. But what we could do is go from mass to moles and then moles to volume. So those are our two steps: mass to moles, moles to volume. Okay? You could also be asked, how do you go from volume to particles? Okay, again, no direct path. So you have to go from volume to moles and then moles to particles. Everything goes through the mole. That's why it is so important. So why don't we take a look at the example problem that is already given to us, and then we'll do one together. So the example says, how many oxygen molecules are in 3.36 liters of oxygen gas at STP? Okay, so like always, you start with what you're given and then try and figure out where you're trying to end up. Okay, well, we're given our number, 3.36 liters. Okay, well, what is liters? Okay, well, here's a hint. It says oxygen gas at STP. Liters is a volume. Okay, so we're going to start with volume. The question asks, how many oxygen molecules are there? Okay, so if we're talking about molecules, remember what we're talking about? We're talking about particles. Okay, so if you look at your mole map, we're starting with volume and we have to get to particles. So you can kind of see, just like before, we have to first go to moles and then we're going to go from moles to particles. Okay, so we write down what we're given, 3.36 liters. That is our unit. Okay, the first step is to convert to moles. So if we look at our mole map, in order to go from volume to moles, we have to go straight up. 1 mole divided by 22.4 liters. So this is the conversion factor I want you to use, and that's already given there to you. 1 mole on the top, 22.4 liters on the bottom. Okay, we do this so that the liters, will cancel. Okay, by doing this, we're now in moles. Now we have to continue, right? The question doesn't say how many moles are there, it asks how many molecules. So we want to go from moles to particles, right? Because molecule is an example of a particle. And in order to do that, we have to follow the arrow, right? We can only go in one direction. So if we follow the arrows, we have to use this conversion factor, 6.02 times 10 to the 23rd particles divided by 1 mole. And that is exactly what is happening here. We do 6.02 times 10 to the 23rd molecules, because that's what we're looking for, divided by 1 mole. So if we were putting this into our calculator, let's just double check. I'm going to start with 3.36. Okay, we're going to multiply by 1. I'm not going to show that step. And then we're going to divide by 22.4. Okay, and I could hit the equals buttons if I want. Okay, that's how many moles I have. But then I want to continue on. I want to multiply by 6.02. Now, times 10 to the 23rd, that's our EE, our exponential notation. That's how we get times 10, and I'm going to type in my exponent, 23rd. So if I hit my equals button, I get 9.03 times 10 to the 22nd, E22, okay? You do not have to list all of these zeros, okay? 2 decimal places is good enough. Okay, so 9.03 times 10 to the 22nd, okay? Do not put E22, okay? You have to put times 10 to the 22nd. Okay, so that answer checks out. Why don't we do the first one together? Okay, do this along as you watch the video. Find the mass in grams of 2.00 times 10 to the 23rd molecules of F2. Okay, so F2 is fluorine, okay, fluorine gas. So we want to know, find the mass. What is the mass in grams? Okay, so that's my ending point. What am I starting with? Well, I'm starting with 2.00 times 10 to the 23rd molecules. Okay, I know I'm going to have to do 2 conversion factors. So, like before, I'm going to start off by copying this here, and then we'll just do a little copy pasting to get our answers. Okay, so I'm given molecules and I want to find mass. So if I'm looking at my mole map, I want to go from particle plaza to mass mole. But can I go here? I cannot. There's no direct path from particles to mass. So what do I have to do? I have to first convert to moles. And then I can go from moles to mass. Okay, so these are my 2 conversion factors, right? If I follow my arrow right along the top, those are the 2 conversion factors I have to use. Okay, so I am going to copy this here. Okay, so I can get my starting point. No point in retyping it all. Okay, but I'm going to type out 2.00 times 10 to the 23rd molecule. So that is my starting point. If I'm here, my first step is to convert to moles. Okay, so I'm going to use this conversion. 1 mole divided by 6.02 times 10 to the 23rd particles. Okay, so 1 mole on the top, and I need 6.02 times 10 to the 23rd. So I can 6.02 times 10 to the 23rd molecules. Okay, so molecules cancels. That is what I want. And 1 mole on the top. Okay, so I'm now in moles, but that's not what I'm looking for. I'm trying to get to mass mole. So I need to go from mole town to mass mole, moles to mass. So I follow the arrow going up and to the left, and it says to do molar mass divided by 1 mole. Okay, well, 1 mole is on the bottom. That is what we want. Now I need to put the molar mass. Okay, well, what is the compound or the molecule that I'm looking for? Well, it's F2, fluorine. Okay, subscript 2 means I have 2 atoms of fluorine. Well, if I go to F, I find that the molar mass is 18.998, which you can round up to 19. Okay, it is so close that you can round it up. So, okay, I'm going to write this here. Molar mass of fluorine equals 2 times 19.00. That equals 38.00 grams per mole. So that number, 38.00, that is what I'm going to put in my conversion factor. 38.00 grams. Okay, now we have everything. Let's double check. Molecules cancel. Moles cancel. The only unit that is left over is grams, which it says find the mass in grams. That is exactly what I am looking for. So how do we put this in our calculator? Okay, 2.00 E23, and I'm going to multiply it by 1 and then divide by Avogadro's number. So I want to divide by 6.02 E23. I can hit the equals button if I'd like. Okay, so that's how many moles I have, but I'm not done because there's another step. I have to multiply by 38. So I'm going to take this number and multiply it by 38, and I get 12.62 grams. Okay, that is how many grams of fluorine there are in 2.00 times 10 to the 23rd molecules. Okay, so for these problems, you're going to have two conversion factors. Okay, you're going to have two steps in your setup. Okay, because you have to first convert to moles, and then you're going to take that moles and then convert it to another conversion. Okay, play around with the copying and pasting until you get it right. Okay,